Hello, this is Ben Geisler. I'll be going over the visitor design pattern today. The purpose of this video is as a makeup video for software engineering, spring of 2015. April 10th was the date that it was recorded, and the main content of this video is meant to be used in a follow-up lab, which we will be doing on April 13th. That is the next Monday of class. So follow along with me and get ready for the lab on Monday. So starting off from the beginning here, visitor design pattern is a very popular design pattern from the Gamma book, from the Gang of Four book, and it's meant to be a behavioral design pattern. So it's all about how things are done, and not how things are created, but how things are actually done. So the idea being that there's different ways in which you can visit functions and classes, and we can obscure the actual implementation from whoever is calling it. So you can generically just say, I want to visit a bunch of things. I want to visit a bunch of different types of objects, and I don't necessarily need to know the full details about what those objects are containing, but I just want to visit them. So it allows for this idea of a separate data structure that can exist, where the algorithm that's calling into that data structure doesn't necessarily need to know the type of class that is going to end up being called or anything like that. That leaves the data structure itself to be able to be evolving separately, getting its new private members, changing perhaps some of its functions that can be called, and doing whatever it needs to do. And essentially it kind of takes the development of the whole piece of software and puts it off in two directions. One direction with the algorithm that's actually calling into the visit members, and one direction with the data structure itself. So what's going to happen is all the data structure elements, we're going to call these elements basically, they're all going to be objects, and they have an accept method which takes a visitor. And that visitor is the thing that is going to be the generic that the algorithm uses to call the visit method. It takes in that visitor, which is a generic, as its data structure that's calling information on. This allows us to use new operations that can be defined and used on elements in that object structure, and that way we don't need to change out the contents of those elements. So it's sort of like a double dispatching call. The accept will call the visit, basically. We're going to call accept with the generic data members that we've made from the parent function, and then accept will call the visit directly. And visit can change depending on what the actual type of the visitor is at runtime. So this is very useful when the structure of the call chain doesn't really change very often. But you may have a whole lot of classes that have all kinds of different ways of responding to events. So we used to use this in the industry a lot for scripting. What I mean by that is we would have a game that had a lot of different actions that could be taken in a scripting language. For example, like an explosion going off, or a door opening, or a cinematic being triggered. Each of those was visited by a parent class. The parent class was the caller of the script function, which would then go down into the actual call, which was doing its thing. All of those relations also that I just mentioned, such as explosion or opening a door or triggering an alarm or triggering a cinematic, all of those are unrelated operations. They're all unique things that go on, and they can be coded uniquely in the visit class. So here's talking a little bit more about, I like to bring up game stuff because it's kind of my background for the last 15 years, but obviously this is very applicable to the rest of computer science as well. It's very applicable to bank accounting type software. It's applicable to compiler design. I'm actually using it right now in some of my graduate level work for compiler design, whereupon the things being visited are the tokens that you dissect the programming language into, such as like an int type or a bool type or whatnot. Each of those is treated differently to the compiler, so therefore it calls a different visit method depending on which one is there. Also, you can think of a bank account in this manner. The concrete object is going to be the checking account or the savings account. The structure of that rarely changes, but there could be new potentially types of checking accounts or savings accounts or what have you, but the structure of them all being a type of bank account rarely changes. We could add a inquiry method here, and if we wouldn't want to change our structure, we could create a simple visitor structure, and we could just call it an account inquiry visitor. So the account inquiry visitor would have visit checking, visit savings, and display inquiry, and that would be attached to an account visitor. And the account visitor could visit the individual types of accounts that are coded. In Java, this would look like the following. We'd have, in addition to have our checking and a savings account, we already have those already exist, but now we're going to have a visitor that knows how to visit the checking account and knows how to visit the savings account. So in code, it looks like the following. You see up at the top here, we have account inquiry visitor implements account visitor. So account visitor is just a generic abstract class that we can derive from. From there, we get our checking account number, our savings account number, and we basically have visit checking account, which does a get account number, visit savings account that does a get account number, and then a display inquiry. So this changes our structure a little bit. We add the idea of an accept in the savings account and the checking account. And that accept is eventually going to call down into the visitor. So accept takes an account visitor. And remember, account visitor is this is inheritance. So account visitor is the parent class of the actual visitors. It is a non-concrete class. And accept can be called with either the checking account or the savings account. So in the case of a checking account, it'll obviously call it with the checking account. In the case of a savings account, it'll call it with the savings account. And then we'll get the correct accept calls down here. Here's another example. So this one I'm going to actually walk you through. So that first example I just wanted to show you quick. I'm not planning on running it. This next example I want to actually run and show you how it's working. The idea is we'd have an interface for operations that are specified in a color-based class and implement in the color-derived classes. So we're going to have a color-based class and specific colors like red, blue, etc. And so the color hierarchy is going to specify a single accept method, and then we're going to have a count and a call method implemented as visitor-derived classes. So when accept is called on a color object, that's the first dispatch right there. It calls accept on the color dispatch. Then visit is called on the correct visitor object of the thing that's being called. So it's calling it on the correct thing at that point. So let me show you how that works. Going to bring up ICS Linux here. It was just easier for me to work in ICS Linux today. So actually, this is how I'm going to compile, but I want to show you it in Visual Studio. So visitor design pattern 1. This is the colors example that I gave you. Same kind of idea as what the bank account example was doing, or even the game example that I came up with, but I always like to start down looking at the main. The main is pretty easy in this case. We're creating a set of colors, red, blue, 2 blues, 2 reds, and then 0 indicating that there's nothing there. Colors are simple. They basically just have an accept method, and then we can derive from those colors and create our own accept methods. We can also have unique functions such as eye and sky for blue. The accept is a virtual that's inherited from, and that's going to just call the particular visit. In the case of the account visitor that we saw before, it called a different visit depending on which class it was. But here we're just calling the generic visit again, which is fine. You can do it this way as well. But you could call specific code here in the accept method, since this is red's accept method, and anyone that calls red accept is going to call this information. So we go through, and now we basically are going to call accept on each of the colors. So we have two types of visitors here. We have a count visitor and a call visitor. And they're going to do different things. See, the call visitor has a visit that says RI. The for red, the visitor for blue has B sky. So when we call accept on count operation, which is basically it's passing in that function, it's calling accept with that function name. So if we take a look at that function name, and we're going in at 0 location, so that would be red, so it would call up to here. So this first one we would trace down through here. We would create all these things. We call accept. That's going to call red of accept, which in turn is going to call via visit. Via visit is going to be different depending on what this is. This is either going to be a pointer to red or a pointer to blue. If it's pointer to red, like it is in the first case, it's going to call R of I. In fact, that's what we see in our printout. It calls red I. Then next it calls blue sky. That makes sense because that's the next one that's called here is a blue. Then another blue sky, then a red I, then a red I. The count operation, meanwhile, is it's doing its thing, which is to count up the number of calls that we've given. Notice that there's two accept calls. One is going to the count operation, one is going to the call operation. The powerful thing about this is you can have any number of visitors you want. As long as you make an accept call on that visitor, then you get that functionality. So accept is a generic thing that just calls vvisit on whatever is being passed in. So the case where this becomes really cool in a game engine, for example, is that you can add new script functionality, or in a compiler, you can add new language functionality, and all you have to do is call accept on it, make sure that it's implemented the visit methods correctly to do their thing, and then you've got new functionality instantly. So it's a nice and fast, easy way to create new functionality without inherently changing the structure of these. If you wouldn't have done it this way, what you would have needed to do, for example, is figured out which you had here. So do we have a red or do we have a blue? Then call the appropriate accept, which in turn calls the appropriate visit. And you would do that for each one. So you could do that with casting. But this gets around having to cast using polymorphism because count operation is passed into accept, and that accept uses this pointer to polymorphically decide which of the ones to call. So that's basically it for that example. The lab that I want you to do is basically to come up with I got the wrong thing open there. Oh, that's week 2's lab. I'm sorry, I've got it on the PowerPoint, I think. Here we go. So this is actually, this should say the 13th that we're going over this. So we're going to implement the code on the previous slide. This is for the account stuff. And we're going to create a checking account and a savings account. And your account is going to make 2 calls, one to each type of account using account visitor. So I've also created some code on D2L for the account visitor. And we can use Java for this, actually. I'm perfectly fine with everyone using Java on Monday. Here's the code. I'm going to put this up moments after the video launches, so no worries, it'll be there. This is basically the code you need, except you're going to need to implement it. This is actually simply creating an account visitor, having a visit for a checking account, a visit for a savings account. And what I'll be asking you to do is to create an actual account for each of these and make method calls on them. So that is it. There's the sample code you can use to get yourself started on the lab. The lab won't be due until next week at the end of the week, but we'll start it on Monday. And I'll probably talk about quite a bit of this stuff at the beginning of class as well. But this video should have you set and going to get some start on some of this stuff. All right, see you in class on Monday, and have a good weekend.